Another triangle here. We're given three sides of the triangle. So to solve this, I have to find the three angles. Obviously, angle P, angle Q, and angle R. Now, I also keep in mind, you know, and the rules for those triangles I mentioned previously come in handy here, because I know the measurement of angle P is going to be the smallest angle because it's opposite the smallest side. I know that R is going to be the biggest angle because it's opposite the biggest side. And of course, angle Q will be somewhere between the measurements of angles P and R. The reason why I want to do this is a situation, if I'm given three sides and I'm looking for an angle, you know, there's a couple things you could do. I mean, first of all, if you want to explore, see, this is a Pythagorean triple. If you know what these are and you explore it, you find that they are. So this will eventually be a right triangle. It's not marked as such yet, so I shouldn't treat it as such, but I could definitely explore to see whether or not it is a right triangle or not. You know, if it obeys the Pythagorean theorem, then it is. But say I didn't notice that 5, 12, and 13 are a Pythagorean triple. Most students don't. They recognize the 3, 4, 5 as sometimes multiples of that, but 5, 12, 13 is not a Pythagorean triple that most students remember. And there's others even yet that are less known by even more students. So when I do in a circumstance like this, I have to find an angle, and if I'm going to use the law of cosines, because that's the only alternative I got. Because if I'm going to use the law of sines to find an angle, I have to know one other angle measurement, and I don't here. I know sides only, and that's it, and it doesn't help me. So I'm going to use the law of cosines, and I'm usually going to use the law of cosines to find the measurement of the biggest angle. Because once I know that I have the biggest angle, then that's the angle that could be right, that's the angle that could be obtuse, and therefore, you know, that's going to be the circumstance that's going to help me there. Now, the law of cosines works well with obtuse angles, and it comes back to that all suckers take calculus idea, you know, and going back to also my inverse trig functions. Remember, you know, arc sine gives us angles in the first quadrant that are positive and gives us angles in the fourth quadrant that are negative. When I deal with triangle situations like this, I'm not going to have any negative angles. So essentially, arc sine would only give me an angle between 0 and 90 degrees for most of this circumstance. So that's the issue. Arc sine, if I have an obtuse angle, arc sine would never give it to me. Whereas arc cosine is defined for angles between 0 and 180. So if there is an obtuse angle there, it's going to tell me I have an obtuse angle, and I'm going to be able to find it by using arc cosine. So that's where that issue with using the law of sines comes in, because if I'm using the law of sines to find an angle measurement, I am typically going to need to use arc sine eventually to get what that actual measurement is. So I'm going to use the law of cosines to find angle R. That's going to give me a measurement, and since I know that's the biggest angle, if I want to use the law of sines to find the other angles, I can certainly do that. So I'm going to find angle R first for that reason. And I set up the law of cosines so that R is the angle I'm using. Since I'm doing the cosine of R on the right, I want side R to be squared alone on the left-hand side. Of course, the other two sides are going to be the 12 and 5s put in their appropriate spots. And I go through and I evaluate this. Now, here's a mistake that a lot of students make here. Once I get to this point, students want to sometimes, at this moment, take the 169 minus the 120 on the right-hand side. The problem is that 120 is being multiplied to the cosine of R. That multiplication would have to be done first before the subtraction can be done. You can look at cosine R as just being a variable. It'd be like me doing 169 minus 120x. I can't carry through that subtraction. They are not like terms. So, you know, I'm not going to be able to combine those together. Now, what I can start doing is I'm going to subtract both sides by 169 to get 0, divide both sides by negative 120 to get that the cosine of R is 0. And, you know, well, what angle gives me 0 when I take its cosine? Well, 90 degrees does. So that, if I don't recognize the Pythagorean triple, would certainly let me know that angle R is 90 degrees. Now, at this point, I could just use basic trig functions. Why? I mean, I could use the law of sines, I could use the law of cosines if I want to find the other angles. They're still on the table. But I could use basic trig functions at this point because I do have a right triangle. So if I say that the sine of angle Q is 12 over 13, based off of me saying, well, opposite leg over hypotenuse, and I do the arc sine of 12 over 13, I get 67.38. And if I do, like, for instance, the tangent of P equals 5 over 12, which means that angle P is going to be the arc tangent of phi 12, which is about 22.62 degrees. Now, these are not the trig functions I had to use. I could have picked any number of them because I have all three sides of the triangle. I could have picked whatever I wanted. I could have also used the law of sines. I could have used the law of cosines to find these angles if I wanted to. So, you know, I do have several other options, but they all should all give me the same answers here. That angle P is about 22.62 degrees, angle Q is 67.38 degrees, and the measurement of angle R, of course, is 90 degrees. This one here, we're going to solve this triangle. So again, what we're missing here, we're missing angle X, we're missing angle Y, and we're missing side Z. So what should I find first? Okay. Again, if I'm going to use the law of sines to find anything, whether it be a side or an angle, I'm going to have at least one pairing of a side and its opposite angle. And I don't have that here. If I know a side, I don't know its opposite angle. And if I know an angle, I don't know its opposite side. What I do have are two sides and the included angle known. In a situation like that is a clear-cut sign to use the law of cosines to find the missing side. That's what I'm going to do here. I'm going to find side Z first by setting up the law of cosines. So Z squared is going to be 6 squared plus 18 squared minus 2 times 6 times 18 times the cosine of 25 degrees, which gives me this. Now again, I'm not going to do 360 minus 216 and then do the cosine of 25 degrees. I'm going to do 216 times the cosine of 25 degrees and take 360 minus that. I get 164.23, blah, blah, blah. I take the square root of that. I get about 12.82 for Z. Now that I know that side there, I can start finding other angle measurements, you know, at this point. Now, if I'm going to find angle Y next, angle Y is the biggest angle, which means that's the one that could be obtuse. So if I'm going to find angle Y next, which I can, I have enough information to do that, I would have to use the law of cosines again. If I choose to find angle X, X is going to probably be the smallest angle, therefore it's not going to be, it's going to be less than 25 degrees. It's not going to be obtuse. I could use the law of sines as an option to find angle X, or I could also use the law of cosines. I mean, so I do have options to find either. So what I found next was angle X because I could use the law of sines, the easier formula, by doing the sine of X over 6 equaling the sine of 25 degrees over 12.82. Also, as a side note, that 12.82, when it came out on my calculator, had more decimal places to it. I rounded it to 12.82. So, again, where I have 12.82 here, I'm using the entire number my calculator gave me by using the memory features of my calculator. So I multiply both sides by 6. I then take an arc sine of that, and I get about 11.41 degrees. And at this point, the easiest way to find angle Y is just to subtract, you know, take 25 and 11.41, add them together, subtract that from 180 to get 143.59. Now again, when I look at the final result, the biggest angle should be opposite the biggest side, the smallest angle should be opposite the smallest side. And then if I use the law of sines as a means of checking, if I do the sine of 143.59 over 18, the sine of 25 over 12.82, the sine of 11.41 over 6, making sure we're in degree mode, they should all be approximately the same. And I should see at least the same numbers for at least 2 or 3 decimal places for those 3 decimal answers I would get.